I wanted to share a bit about a project I've been working on, which is about how you might use voice for digital design. The project is currently implemented as a Figma plugin, so that's what this thing in the corner is. And there should be timestamps for the different features and segments, so feel free to skip ahead to any of those if you like. But to begin with, I'll just ask the system to start listening. Then, once it's listening, it will transcribe everything you say. And this is actually intentional, so you can understand exactly what the system hears, and then if it makes any mistakes, that transcript can help you with understanding what went wrong. Of course, one of the downsides is it will always transcribe everything you're saying, even if that's relevant information, which can be both a bit distracting, but it can mean the system may take extra time to respond, as it needs to process that. So you might have seen it reasoning down here. Yeah. Then all of these here are just standard Figma design objects. You can interact with them using a mouse, for example, moving them around or resizing them, but they've all been given unique identifiers, which you can see here. And these enable you to perform actions on them using voice commands. Most of the actions I've developed for this prototype were chosen by analyzing lots of different designer workflows and by identifying the most frequent and most important actions. And one of the most common design actions you might want to do is selecting objects. And this should be really easy with this tool. For example, all you would need to say is something like select cloud. Select plant. Select Pluto. And instead of saying select, you could also say, for example, click frost or click sun. And here's an example of where the transcript was useful. You can see that it didn't identify sun and it heard on instead. So I can try again. Click sun. Then if we want to, we can also select multiple objects. For example, select frost, Pluto, and plant. Or select cloud and Pluto. Another really frequent action you might want to do is zooming to objects, which is just as easy. For example, zoom to plant, zoom to Pluto, and then maybe we want to see everything again, and you can just say zoom to show everything. Then if we just select nothing, and maybe zoom to focus cloud, then I can show you how basic moving and resizing works. There's quite a few different ways to do this with this tool, and the one I'm about to show you is probably not the best way to do it, but it might be the simplest way to get started. I'll just show you now. For example, you could just say resize the right side of cloud by 50 pixels, resize the bottom side of cloud by 50 pixels, and maybe we want to try and align the top of cloud with the orange object. So we could try like move cloud up by 100 pixels. But you can see that's too much. So maybe we want to move it down by 50 pixels. Yeah, but you can see it's a bit hard to work out pixel by pixel in your head. I don't know if you just noticed there, but instead of having to say cloud, I could have just referred to it in a more ambiguous way by saying move it instead. This is because it can use the design history to work out what you meant. I'll just do another quick demo so you can see that in action. Move cloud down by 100 pixels. Then move it up by 10 pixels. And then move it up a little bit more. So yeah, you can see you don't necessarily need to refer to cloud explicitly, and you can even use slightly more vague commands like moving things a little bit or stuff like that. And that's because that's achieved in the reasoning step, which is actually performed by a lightweight LLM. So it doesn't have the strongest reasoning capabilities, but it can help to do simple reasoning steps such as these. But yeah, you might have seen it's quite hard to do this alignment like manually by moving pixels. So I'll show you one of the other ways of moving and resizing objects. So to do this, what I want to do is show grid. And then if we zoom out to show everything, you'll be able to get a better view of it. So this grid is made by using the different edges of the objects, and it was inspired by something which is quite common in voice control systems called a mouse grid. But this one is a more contextual mouse grid, which takes into account the environment or the design space. So I'll show you a few things we can do with the grid before showing you how we can get that alignment we wanted. But one of the simple things we can do is we can move objects based on the grid. And this can be quite helpful for alignment as well. For example, I can move Pluto to cell 49. And that would get it aligned with plants. I could also move it to cell 53 instead. But I'm actually going to put Pluto back in cell 17. So now I'll explain a bit about how we might align that edge. So first I'll zoom to cloud again. Explain a little bit first, but basically each of these objects is given a north, east, south, west identifier, and we can use these as references. And the grid is actually also given these as well. So each cell has a north, east, south, west identifier. Maybe we want to move the north side of cloud to the north side of cell 36. And the system's able to do that. Maybe I'll zoom out to show everything. And then I can show you a few more of these interactions. For example, maybe I want to resize the west side of Pluto to cell 15 west. Or resize plant south to 44 south. Or maybe we want to get more precise, and we can do that by increasing grid density. Increase grid density. So now we can do more precise movements, like resize Pluto west to 95 west. Or resize Pluto east to 109 east. And we can get even finer detail. For example, if we increase grid density again. But of course, the more density we have, the more overwhelming the grid can get. One approach to try and help with this issue, I've made it so the numbers won't show for very small grid cells, but obviously that will mean you have to zoom into objects then to be able to see them again. For example, if I zoom to cloud, then we can see those numbers again now, but it can just get a bit overwhelming. So that was a summary of my prototype for this project. Obviously it's a bit basic at the moment, but hopefully it shows designing with your voice isn't impossible. When I tested this prototype against off-the-shelf voice tools that use the classic mouse grid, it was able to effectively outperform them on some key design tasks. So I think there's definitely some potential here. Obviously there's lots of challenges as well, and you likely saw some of them within the prototype. Thanks for watching, and feel free to leave any feedback in the comments, or if you prefer, you can reach out to me personally. And yeah, thanks again, and have a good day. Bye.